let's go over the chapter 11-12 practice quiz. Hopefully you've tried it on your own first and either done it all and just want to check your answers, or if you're struggling with some of the problems, hopefully when I go over it, it'll make sense to you how to do them. All right, so number one says write an exponential model in the form A0 e to the AT for a yeast population starts with 120 cells at t equals 0 and has 800 cells at t equals 4 hours. All right, now these are the easy ones because you know what A0 is. So number one, you write the number of yeast cells as the starting number, e to the AT. Sometimes the A can be an R. It doesn't matter what the letters are. Really, I should make that an R, but try to match the A's here. That's why it's like that, but whatever. But R makes sense because it's the rate, right? The continuous growth rate. That's what we're after. Okay, we know what A0 is because at t equals 0, there's 120 yeast cells. So these are the easy ones. So actually, we can write that's equal to 120 e to the AT because we know we start off with 120. Now we use the one data point we have that there are, what, 800? There's 800 cells at e to the t is 4, so I'll put that first, 4a. The only thing we don't know is a now. So we figure out a, we know everything we need to know about how many there are at any time we want. So let's see, I'm going to put the 120 over here. So 800 divided by 120 divided by 120 is 6.6666, okay, 6 2/3. So 6.66, I'll put lots of 6's there, is equal to e to the 4a. We need to get rid of that e. The way you get rid of e's is you take the natural log of them. So yeah, but then you got to do the same thing on both sides. So the ln of 6.667 is equal to the ln of e, which makes it go away. So that's just 4a, right? Because the ln's cancel out e's. That's the whole point of logarithms. They're invented to get rid of exponents. Or a is ln of 6.667 divided by 4. So I get that's like 1.897. So a is equal to 1.897 divided by 4. 897 divided by 4. Yeah, which is, divide that by 4, which is 0.474 or whatever. So those 0.474 is good enough. So our growth rate, continuous growth rate, if these yeasts are continuously growing, is about 47%, 47.4%, right? So the growth rate, the continuous growth rate is if they're growing continuously, is about 47.4%. That's pretty fast growth, right? Which, yeah, 4 hours later, there's 800 of them. That's pretty fast growth. Okay, now if we want to know the hourly growth rate, because we're dealing with hours here, right? What is it when t equals 1, the hourly growth rate? Then we can find b. We can put it in the other form, which is not hard to do. If we want to write this as a0b to the t, then b, we have right now e to the 0.474 t, but that's the same thing as e to the 0.474 to the t, right? Because you multiply exponents when you have a power to power. So this would be our b. Our b is just e to the 0.474. So you learn how to do that in your calculator. So yes. So I'm going to go 0.474 e to the x, and I get about 1.59999, so pretty close to 1.6. So this would be 1.6 to the t, which means that the hourly growth rate is about 0.6 or 60%. So the hourly, in other words, when t equals 1, we're dealing with hours here. So the hourly growth rate is everything above 1. In this case, it's 0.6, which makes it 60%. So after every hour, there are 60% more yeast, or they're continuously growing within the hour at 47.4%, which they're the same thing. Okay, so again, the B thing tells us what the hourly growth rate is, while the E tells us what the continuous growth rate is. And they're both interesting and good to know. All right, number 2 is the same idea. But now we don't know A0. We don't know what it is in the beginning, so slightly harder. We have to find what A0 is, okay, because we don't know what it is. So, but it's the same idea, but now we have to do the two equations and two unknowns thing. And again, I said there to do it in e to the at. We could have done it the other way too, because it's real easy to switch. So you could do it either way and switch. But all right, let's do this. So we have to have the two values. Okay, so we know that there's 260 at t equals 2. So 260 equals a0 e to the 2a. I like putting the t first here because that's 2 hours. And then there are 1900 cells equals a0 e to the 9a at 9 hours. So e to the 9a, or t equals 9. From those 2 points, we can figure out a0 and what a is, this little a. Now, what you first do is divide them. And you can go this one divided by that one, or that one. I always write them like this, but I like to divide the big by the small because it just feels better. But you could get a decimal too, it doesn't matter. But when you divide them, you get rid of a0, and then we just have to figure out what a is. Okay, I like going big divided by small, so this divided by that. So that'd be 1900 divided by 260. So 1900 divided by 260. I get 7.3077 about 7.3. I can't remember it well. I just kick it up to 7.30769. So 77 equals the a0's cancel. I'm doing this one on the top. So e to the 9a divided by e to the 2a. When you have the same base, you subtract. 9a minus 2a is e to the 7a. So e to the 7a. Okay, now we got to get rid of this e because we want a. So you take the natural log of both sides. So the natural log of 7.3077 is equal to, that's a 7 there, is equal to 7a because natural log of e makes it go away. ln of e makes it go away, so 7a. Or a is equal to natural log of that divided by 7. So natural log of that is 1.989. 1.989 divided by 7. So divide that by 7. I get 0.284, about 0.284. So our continuous growth rate is 0.284. Now we can use either one of these equations to figure out a0. Your choice. Let's use the first one. What the heck? So we have 260 equals a0 e to the 0.284 is what a is. So we plug in e to the 2 times 0.284, and that's, so what is that? So e to the 2 times that, so you can figure out what that is here. So 2 times 0.284 seconds. I get, that's 1.76. So 260 equals a0 times 1.76. 1.76473. How far do you go? I don't know. That's pretty good. 473, 1.76473. That's pretty good. Divide that over here. So that would be a0 then, I get would be about 147.3. All right, so we start off with 147.3 yeast cells when time was 0. That's what this says, which makes sense, right? 260 at 2, 1900 at 9, 447.3, that's a reasonable answer. If I'd gotten like 1 or something, maybe not, but that looks reasonable. So finally our model is A is equal to 147.3 e to the a, which is this, 0.284 t. Okay, so our continuous growth rate is 28.4%. They're growing continuously at 28.4%. Or if we want to know the hourly growth rate again, so the hourly, how many more do we have every hour? It would be, let's see, e to the 0.284, right? Because that would be that to the t, so that would be our b there. So we got to figure that out. So what's e to the 0.284? So 0.284, I get 1.328 by well, let's say 1.33. So that'd be 1.33 to the t, which means everything past the 1 is the growth rate, the hourly growth rate, so about a 33% hourly. It's whatever's past the 1 there. 33% hourly growth rate, which makes sense. It should be a little bit bigger. Every hour it's 33% bigger, continuously grows at 28.4%, which means every hour it's 33%. That's the same thing. If you put your money in the bank at 28.4% interest, like compounded hourly or something, which would be pretty close to continuous, that would mean at the end of the year you'd have 33% more money. Okay, that's a different way to look at it. All right, that's number 2. Number 3, you invest $1,000 at 6.3% interest for 10 years. How much money will you have if it's compounded quarterly, which means 4 times a year? So 4 times a year they give you interest. Not very good. Be better if it was 1,000 times a year. But still better than once a year. So we have to use the continuous, not continuous formula. So we have that the amount of money you have is the principal times 1 plus the rate divided by the number of times per year. It's compounded times number of times per year. It's compounded times how long you have in the bank. And you got to make sure all your units match. I'm not going to try to fool you. We're dealing with years now. Quarterly means 4 times a year. So here we have our principal is 1,000. 1 plus the rate is 6.3, and always change it to a decimal. We never do math with decimals. So 6.3 is 6.063. Be really careful of that, right? 2 decimal places is 6.3. I have a lot of people put 0.63. 0.63 is 63%. So be really careful changing a decimal. Move it over 2 decimal places, 6.3, 1, 2, so this is 0. Divided by 4 to the 4 times time, I said 10 years, so 10 years there. And again, it's because n equals 4, because we're doing it quarterly, 4 times a year. All right, now it's a math problem. So you plug in, that's 1,000 times, okay, that divided by 4 to the 40th power. So what's that? So 0.063 divided by 4 equals that, plus 1. I get 1.01575, 1.01575 to the 40th times 1,000. So 40 times 1,000. And I get, you'll have 1868.41. 414, but whatever, that's okay. So at the end of the year, you're going to have $1,868.41, which seems like a lot. Did I do this right? Oh, sorry, it's after 10 years. Phew, I was thinking end of 1 year at 6.3% interest. That doesn't sound right. This is at the end of 10 years. Yes, okay, that makes more sense. So into 10 years, you put money in the bank. 6.3% interest is pretty good. You're not going to get that in a bank nowadays. That's pretty good interest. Pretty, typical. Maybe in the stock market you can get that or something. So for 10 years, your $1,000 turns into 1868 if it's compounded quarterly. Now, if it's compounded daily, it'll be more than that. You could figure it out. Plug in daily, plug in 365 here, 365 here, 365 there. See how much more money you'll make. So the next one, B, says now, what if it's compounded? Oh, this is A, by the way, part A. So part B, what if it is continuous now? Okay, that's the ultimate. So we get 1868 4 times a year, but now we're going to do it continuously. So then we use the formula. The amount of money you have is the principal e to the rate times time, continuous rate times time. So that would be 1,000 e to the it's 0.063, but now we're going to say that rate is continuous times 10. Time is 10 years, so that would be 0.63. So e to 0.63. So 0.63 times 1,000, and I get 1877.61. 1877.61 at the end of 10 years, which, okay, it's not a whole lot better, is it? Only about $9 better. So again, yeah, continuous is best, but as long as it's even 4 times a year, not so bad. It's not that much less. You know, it adds up, but still, it's not so horrible. So 4 times a year isn't so horrible. Okay, finally, how long will it take to triple your money if it is compounded continuously? So we use this formula. We want 3 times the money. So let's say you put in the principal. You want to have 3 times the principal. Whatever you put in, you want 3 times that. Whatever you start off with, right? So you start off with the principal. When do you have 3 times? So you plug this in. E to the, and our rate was 0.063 t. So however much you put in, you want 3 times that. Okay, we could put in 1,000, and then we have 3,000. It's still going to be 3. Divide both sides by p, right? And we have 3 over here is equal to e to the 0.063 t. Okay, so it doesn't matter what you put in, just 3 times that, because you always divide it, you get 3. Okay, so we take the ln of both sides. So ln of 3, ln of e, the e goes away, is 0.063 t. Or the time is the natural log of 3 divided by your interest rate. Okay, so the natural log of 3, who knows what that is? It's e to what power is 3? It's going to be a little bigger than 1, right? Because e to the 1 power is 2.71828. So it's going to be something a little bigger than 1, but let's figure out what that is. 3 natural log 1.0986. So that's 1.0986 divided by your interest rate into the decimal, 0.063. And I get that that is equal to, divided by 0.063, 17.438, let's say 17.44. So 17.44 years. If you want 3 times the money at 6.3% interest rate, you want to triple your money. It's going to take about 17 years, 17 and a half years. Okay, so yeah, so you put $1,000 in the bank, you wait 17 and a half years, about lifetime, you guys, you're going to have $3,000 in the bank. Pretty good. Now, if you have a higher interest rate, it's better. So basically, it's the ln of 3 divided by your interest rate. No matter what the formula is, if you want to triple your money, it's always the ln of 3 divided by your interest rate. And if you don't like decimals here, change that to a percent. You just multiply this by 100. So the formula to triple your money is 109 1.0, multiply that by 100.86 divided by your rate in percent, because we multiply this by 100, multiply that by 100, and that will give you your tripling time. Take 109.86 divided by your rate. So let's do that. Let's say you get 10%. That's easy math. And you have 10% interest, so you divide this by 10. That just takes away, right? Divided by 10, it goes to there. It'd take about 10.986. I mean, that's really close to 110. So 10.986 years, about 11 years. This is about 110, right? Let's call it 110. So tripling is about 110 divided by your rate in percent. That's how long it takes to triple your money. 10% takes about 11 years. You get 5%, takes 22 years. You get 100%, it takes 1.1 years? Oh, yeah, 1.1 years to triple your money. Wow, that's pretty good. At continuous interest rate. This is at continuous interest rate. Okay, so the same thing works if you want to double it. If you want to double your money, instead of a 3, this is a 2, and then it's the ln of 2. It's the ln of 2 divided by the rate. And if we change that to a percent, the ln of 2 is 0.693 or something. Change that to percent, multiply by 100, and it's approximately 70. So it's about 70 divided by the rate in percent. And that was one of the problems in the book. So if you want to double your money, you always take about 70, divide it by the rate in percent, because we multiply by 100. And that's how long it takes to double your money. Again, if it's a continuous interest rate, or if it's compounded pretty often, even per day is good enough. That's about how long it takes. So to double your money at 10% interest rate takes about 7 years. Yeah. Okay, cool. All right, that's number, now part D says, what interest rates needed to double your money in 8 years with continuous compounding? Okay, so this is a little bit different. We want to double our money in 8 years. Now we're going to solve for R. Okay, so a slightly different problem. So doubling our money, we can use the formula I just worked out. Okay, we know that the ln of 2 divided by R is equal to let me see. That is the interest rate. That's the doubling time is equal to the time. The time to double your money is the ln of 2 divided by R. We want to double our money in 8 years. So this is equal to 8. So ln of 2 divided by the interest rate is equal to 8. If we leave it as the ln of 2, this gives us a decimal. We multiply this by 100, multiply that by 100, we get an interest rate. Okay, so that works. So our rate then is to swap those two, ln of 2 divided by 8. So let's do that. So ln of 2 is, I know it's about 0.6369 something, 693 divided by 8. It's about 0.0866, whatever. So 0.0866, or as a decimal, as a percent, about 8.66%. So if you want to double your money in 8 years, you need about an 8.66% interest rate. Okay, so again, this comes from the formula that we already worked out, that the natural log of 2 divided by interest rate is the doubling time. If you know the doubling time, you just go backwards. Pretty cool. If you want to know tripling time, we change that to 3. If you want to know quadrupling time, change it to 4. It always works out that way because the 3, you just change this to 4 or 5 or whatever, and you end up getting the same thing. Okay, hopefully that all makes sense. Now, let's do an interesting population problem. Number 4 here. So, when does it take, how long does it take for populations to triple or double and all that kind of stuff? It's always the same idea. Okay. So, number 4, from 2002 to 2014, Germany's population, I made this up by the way, I don't think this is real, increased from 65 million to 73 million, and France from 48 million to 59 million. Notice France increased faster, right? So France increased by 11 million and Germany increased by 8 million. So we know that France's population is growing faster. It has fewer people, but more increase. So assuming exponential growth, when will they have the same population? France started off smaller, but it's growing faster. So we want to know about when will they be equal. Okay, so the good thing here is I gave you the starting numbers in 2002. So let's call 2002 times 0. Okay, so t equals 0 in 2002, and t equals, then I say 2014, that's t equals 12. So t equals 12 in 2014, and at t equals 0, the population of Germany was 65 million. So let's call it G for Germany. So Germany was 65, and okay, do we want to use B to the T, or do we want to use E to the RT? Doesn't really matter. I'm going to use B to the T, so t equals 0, it's B to the T. That's the formula for Germany. They started off with 65 million, now not 65, we know we're talking millions here. It's writing all those zeros, 65 million, what's the point? We just know we're going to get our answer in millions. Okay, that's another trick. So one trick is calling t equals 0 2002, then later on we can always figure out the date by referencing that. The other trick is just don't write out million. Okay, then France starts off with 48 million. So we know that France is, well, let's figure out Germany's first. Okay, this is our formula for Germany. Now we have 2 data points. T equals 0, we have that, but we also know that 2014 t equals 12, they have 73 million. So there are 73 million equals 65b to the 12th. from this we can figure out b. Okay, because we know a is 0. Yeah, that's what I just said. So let's see, put the 65 over here. So 73 over 65 is equal to b to the 12th. There's two ways to do this. We could take the natural log of both sides. Let's try doing it that way. Take the natural log of both sides. So ln of 73 over 65 equals ln of b to the 12th. We want b, but b to the 12th, we can put the 12 here in front, and then we can solve for b. But that's, we still have a b inside the parentheses later on. We have to put those to e. That's not a good way to do it. The better way to do it is just take to the 1/12th power. Okay, for these, just take to the 1/12th power of both sides. So to both sides to the 1/12th, both sides to the 1/12th. 1/12 times 12 is 1, so we get b. So what's 73 over 65 to the 1/12th power? So 73 divided by 65 to the 1/12th. So I go y dx 1 divided by 12. I get 1.00972 about. So b is equal to 1.00972. All right, so Germany then is, our formula for Germany is g is equal to 65 times 1.00972 to the time. That means the growth rate in Germany is about 0.9%, 0.97%, it's about 1%. It's only growing at 1%. Now I do the exact same thing for France. Okay, so let's do this for France. Now it's practically the same formula. France, we know that for France, we said they started off at 48. So we know that France is 48, b to the t. And we know that in 12 years, it's 59. So 59 is equal to 48, b to the 12th. And now we do the same thing. So 59 divided by 48 equals b to the 12th. We raise both sides to the 1/12th power. Both sides to the 1/12th power. And we get that b is equal to 59 divided by 48 to the 1/12th. 59 divided by 48 equals that. Y dx 1 divided by 12. I get 1.01734. 1.01734. I'll stop there. So for France, we have it's 48 times 1.01734 to the time. That's France's growth rate, and here is Germany's growth rate. And again, it makes sense. We know France is growing faster. Germany is right about 1%, 0.972%. France is 1.734%, almost double the growth rate. Which, again, we know it's growing faster, so that makes sense. You know, I can check and say, okay, yeah, it's probably right. I don't think I made a mistake here. It looks reasonable. Now, when do they have the same population? We set those two formulas equal, and we solve for time. Okay, so that's the last part. So I'm going to keep the formulas there, set them equal, and we solve for t. So we have Germany, 65, 1.00972 to the t is equal to France, which is 48 times 1.01734, 01734 to the t. All right, now we figure that out. Now, what if I'd said, which I probably will in the quiz and stuff, the real quiz, when does France have 2 times as many people? Because remember, France is growing faster. So Germany can't ever have two times as many people, maybe in the past. But let's solve for when France is 2 times as many people. Then you would put population of France is 2 times Germany. We would put the 2 on this side, right? So France is 2 times Germany. And like I said in class, you got to be really careful. Think about that. When is France 2 times Germany, right? So you want to know when population of France is 2 times the population of Germany. So you multiply Germany by 2. If we want to know when it was double the population, when did France have 2 times people? But this time I just said the same number of people, so it's not that way. And now we solve for t. So I don't know, let's put the 48 over here and this number over there. Okay, I like having big numbers divided by small numbers. It's easier to deal with. So I'm going to put the 48 over here and this one on that side. So I have 65 over 48 equals this number, 1.01734 to the t, divided by 1.00972 to the t. Okay, so just, yeah, dividing both sides by that one, dividing both sides by that one. And now I get some numbers out of this. So 65 divided by 48 is 1.354. Keep a lot of decimal places. It makes a difference. 1.354. Now here, this is the same. If they're both raised to the t power, it's the same thing as 1.01734 divided by 1.00972 to the t. Okay, if they're both raised to t power, you can do this. So let's figure out what that is now. So let's see. So 1.01734 divided by 1.00972. 1.00972. I get 1.007546. You gotta keep lots of decimal places. So 1.354 is equal to 1. What did I just say? 0075. 00. Not thinking down too far. 1.0075466. Okay, that's good enough. To the t power, right? To the t power. So that number divided by that number is this. Now we want t. Okay, how do we get that t down? So to get that t out of here, to solve for what time that is, we have to get rid of the exponent. And so we know how to get rid of exponents, and that is by taking the log of both sides. Okay, that's what you do. So let's take the log, doesn't matter which log we use, let's take the ln of both sides. So the ln of 1.354 is equal to the ln of this, but this is something raised to power. So that's t times the ln of 1.0075466, right? Using the property that the ln of a number to a power is equal to the power times the ln of the base. So the natural log, or any log, of a base to a power, you can put the power in front, put the t in front, and the ln of what's inside. That's how we get our t out. So now t is the ln of that number divided by the ln of that number, right? Just put this big thing on the bottom. So t then is equal to the ln of this divided by the ln of that. So I have that on my calculator already, so I'm going to do that thing. So I get 0.007518, and then ln of 1.354, 1.354 ln, I get 0.30306, and divide those, divided by 0.007518, and I get 40.3 years. 40.3 years. So it'll take about 40 years for France's population to be double. Now, what year is that? I say, when will they have the same population? Well, and t equals 40 years from 2002, because 2002 is times 0. So the year would be 2002 plus 40, so 2042. So in about 2042.3, but okay, I'll put the 0.3. So the year 2042.3, so whatever that is, 1/4 of the way through March, something like that, in the year 2042. All right. Pretty tricky. Good stuff. All right, now I just have a bunch of algebra problems. And this video is 34 minutes long already. Oh my gosh. Oh well. Good thing you can fast forward and stuff. Just pause it. All right, so let's work through these algebra problems. Hopefully they don't take as long. All right. Okay, first one, number 5. we have the log of x equals 2 plus the log of x minus 16. Log, again, without a base means it's base 10. So we're going to talk about log base 10. We want to find out what x is. What x makes this true? Let's see. If we have a base 10 log, what we do to get rid of logs is raise it to the 10 power, right? 10 power and log cancel. So I'm going to raise both sides to the 10 power. So I'm just going to kind of cheat and do it like this, right? So this whole thing raised to 10 power, 10 log x raised to 10 power. Well, 10 the log cancels. So over here we just have x. And over here we have 10 to the 2 times 10 to the log of x minus 16. Okay, and where this is using the rule that 10 to the a plus b is equal to 10 to the a times 10 to the b, right? If you have the same base and you multiply them, you add exponents. So here we have an exponent that's added, 2 plus, which is like this times that, right? Because again, if we add those two together, we add those two to the same base, we get that back. Okay, now it should look clear what to do. So 10 squared is 100, that's 100, and 10 to the log, well, that cancels. That's the whole idea. Power to log, they cancel, so that's x minus 16. 10 to the log cancel, we're just left with the x minus 16. Okay, now it looks like a very doable problem. X is equal to 100x minus 1600. I think 100, 2 zeros, yep, that's right. Let's put this x over here, make it 99x. Put the 1600 over here. So 1600 is equal to 99x. I think that's right, minus 1, yep. Or x is equal to 1600 divided by 99, which is something a little over 16, right? What do I do with my calculator? Here it is. A little over 16. So 1600 divided by 99. 16.1616, whatever, so about 16.16. Okay, and now check it. If you're worried it's a quiz, plug the number back in, plug x back in. Is 16 minus 1.16 here, add 2 to it, the same as log of that? See if it works. I'm pretty confident it does. If it doesn't, let me know. Hopefully it works. Okay, number 6. Write in the form, okay, 5 times 3. We have this thing 5, 3.4 to the 2t minus 3. And we want to write it in the standard E form. We want to write it as a0 e to the at. Okay, so first we got to get rid of this stuff here. So this is 5, which is 3.4, 5 times 3.4 to the 2t times 3.4 to the minus 3, right? Because same base, you add exponents, 2t plus negative 3 is 2t minus 3, yep, that's right. Let's see, this is the same as 5 times 3.4 squared to the t. Now we use a rule where 2t here is like, you get multiply exponents, so 2 here, 2t is 2t, and this is just 1 over 3 to the 4th, right? 3.4 cubed. So that's just a number. So 1 over negative power in the bottom cubed. Okay, and this is 3.4 squared, so this is 5 divided by this on the bottom, so it's 3.4 to the 3rd power. 3.4, I get 39.304. So 5 divided by 39.304, that takes care of the 5 and that. And then 3.4 squared, yep, 3.4 squared is 11.56. So that's 11.56 to the t. If we wanted it to the b to the t form, we'd be done. Okay, that would be the b to the t form. But we got to do that here first. So let me do that. So 5 divided by 39.304 is 0.1272. So this is 0.1272, 11.56 to the t. Which is a perfectly good way to write it. This is the b to the t form, but I said this one, so we got to change that. So basically, what that means is we got to make this equal to e to the a. Okay, because, yeah, so here's how you do it, right? If you have b to the t, that's the same thing as e to the ln of b to the t, because e and ln cancel. So that's just saying b to the t equals b to the t. But now we can put the exponent in front. That's e to the t ln of b. Or ln of b is the a. So the a we want is just the natural log of b, and then we can write it that way. So I just take the natural log of that, 11.56 natural log, 11.56, take the natural log of that, I get 2.44, it goes on forever. Not a good way to round off, 2.44755. Let's say 2.448. So this is the same thing as 0.1272 times e to the 2.448 roughly t. Okay, so you have that number to the t or e to the 2.448, where again the a is the ln of the base. You take the ln of the base to write it as that. So natural log of that is 2.448. All right. So, which again, what this means is 11.56. Well, yeah, this is a huge growth rate. 11.56, right? This gets bigger really, really fast. So, okay, anyway, yeah, that's how you do that, how you change that. It's really easy if you have the b to t, just take the natural log of the base, and that's the a part. You just write that as a and write it that way. And the a0 stays the same. The number in front stays the same. That's what there is at t equals 0, no matter how you write it. Phew, moving on. 7, solve for x again. I'm going to go through a marker during this quiz. Okay, so number 7, we just find x. So we have 5 to the 2x minus 1 equals 4 to the x. 5 to the 2x minus 1 equals 4 to the x. All right, so we want to know what x is. So we have these crazy 5 here and a 4 there. We got to get rid of those, right? We want those, bring those x's down. The way you get rid of exponents is you take the log of them. Any log works. I like using ln. Let's take the ln of both sides. So ln of 5 to the 2x minus 1 equals ln of 4 to the x. Now we use the property that we dearly love, that if something to a power, the powers can go in front. Power can go in front. So this is 2x minus 1. Make sure you use parentheses, right? That whole thing in front of the ln of 5 equals the x in front, x ln of 4. ln of 5 is just a number, ln of 4 is just a number. So let's just get rid of those right now and get some ugly decimals. And again, then you got to wonder how many you should keep and everything else. Here's my calculator. So what's 5 ln? 1.609, let's say 1.61. So 2x minus 1 to the 1.61 equals x times, so let's put that first, ln of 4 ln 1.386 times x. 1.61 times 2 is 3.22x minus 1.61, right? 1.61 times that's this. Yep, that's right. Equals 1.386x. Let's put the x over here and the 1.61 over there. So 3.22 minus 1.386. So minus 1.386 is 1.834. So 1.834x equals 1.61, or x is 1.61 divided by that. So I get that that's equal to 0.878 or something. 0.878. And again, keep lots of decimal places and you should be good. So it's about 0.878. Okay, and then you can check it out. Try it out. Put it back in. See if it works. See if those things are equal. That's a good thing to do in a quiz, right? Make sure you did it right because it's so easy to make mistakes. Okay, and this is not a timed thing. You should have plenty of time. Okay, it kind of is. You have 2 hours, but 2 hours should be plenty. Though it's taking me 45 minutes, but it takes longer to explain it, right? I could do it faster if I was just doing this, I'm pretty sure. Okay, number 8, another solve for x. So here we have that the ln of x minus 2 plus the ln of x is equal to 0. Okay, when you have ln's, you get rid of them by raising everything to the e power. So you raise all this whole side to the e, and you got to raise this side to the e too. Okay, then we use, this is a plus here, right? So this is like e to the ln of x minus 2 times e to the ln of x, because same base, they add. So it's an e to this plus that is e times e, right? And that's equal to e to the 0. Don't forget, this is not 0. E to the 0 is 1. Okay, it makes a difference there. So that's always, people always think, oh, it's 0 over here. But no, e, raise it to the 0 to the e power is 1. Now here, the e and the ln's cancel. That's why we did this. So e to the ln's cancel, so I have x minus 2. And e to the ln's cancel, so that's just an x left, is equal to 1. And now it looks like a pretty easy problem, right? So that's, let's see, x squared minus 2x, equals 1. Let's put the 1 over here. X squared minus 2x minus 1 is equal to 0. And now you really hope that you can factor it, but you can't, can you? Can you? No, x minus 1 times x minus 1 will give you a plus 1 there. So we got to use a quadratic formula. This is terrible. Oh well, it's not so bad. So x is equal to negative b, to be 2, plus or minus the square root of b squared, which is 4, minus 4 times a, which is 1, times c, which is negative 1, divided by 2a, which is 2. These at least are pretty friendly numbers. Let's see. 2 divided by 2 is 1, so it'd be 1 plus or minus this square root 4 minus negative 4, right? So 1, these are all 1s, but negative 4 is 4 plus 4, so that's square root of 8 divided by 2. So we can just leave that as the answer. 1 plus or minus, we have 2 answers, right? 1 plus square root of 8 divided by 2, and 1 minus square root of 8 divided by 2. That would be what x is. Now you could decimalize that, plug it back in, again, see if it works. Okay, the last one. We have, so number 9, I say solve this thing. 2 to the negative x equals x minus 1. All right, now I say here using Desmos, but let's say you don't want to use Desmos, you just want to solve it. So how would you solve it? Let's see, we have a 2 to the negative x. To get rid of this 2, you take the natural log. Any log works. I have a natural log and a log in my calculator. I could take log base 2, but I don't have that in my calculator. So I'll just take the natural log of both sides. So ln of 2 to the negative x equals ln of x minus 1. This works because that brings the negative x in front. So negative x times ln of 2 equals ln of x minus 1. Okay, ln of 2 is a number. It's like 0.693. I remember that from the earlier problem. So negative 0.693x is equal to the ln of x minus 1. But we still have an x here and an x on the other side. We haven't solved for x. So how do we get this rid of the ln? We raise both sides to the e power. So so now we have e to the negative 0.693x is equal to e to the ln gets rid of that is equal to x minus 1. But we still have an x up here. How do we get rid of that? We take the natural log of both sides, and we can go on forever. You can't solve this. You can't solve this. Now, we could guess and check or something, but you can't solve for x in this case. That's why I say use Desmos. It's real easy. You plug this formula into Desmos, you plug that one, and you see where they cross. Okay, so let's do that. I'm going to turn on my computer here, my screen, and show you how to do that. So I'm going to bring up Desmos. Forgot that I was going to have to do this here. So 2 to the negative x the other one? X minus 1. Okay, so if you can see beneath all my writing here, I plug in 2 to the negative x, is the red one, x minus 1 is the blue one, and they hit right there. Okay, when do those two things equal? They're equal right there, and the nice thing is that there's a whole bunch of writing here on top of everything, so we don't need all that. All we need is that equation up there. We're done with all the writing. So that's where they're equal, and the nice thing about decimals is where they cross, you can click on it, and it will tell you the answer. So let me do that. Click on it there, and there it goes. It tells you the answer. The x value is 1.383. So the answer is, to make this work, x is equal to 1.383. Try it, plug it in. Is 2 to the negative 1.383 the same as 1.383 minus 1? And it should work. Okay, so again, sometimes you can't solve things. That's just the case with math. And then you do it numerically. You can't get the exact answer to a million decimal places. Decimal only tells you the 3, but that's still pretty good. You can do as many decimal places as you want. You know, you could, I don't know if decimals can, but you know, there's graphical ways like this to do it, but sometimes you just have to graphically solve it. And it's a lot easier, right? Not to the algebra, just plug it in and see where they're equal. So, all right, good. Okay, good. Hope all those make sense. On the regular quiz, it'll be very similar. He's just applying all the rules that we've learned and being really careful, of course, making sure your answers make sense. And check your answers where possible. And then you should do really well. All right, thanks for listening for this whole 52 minutes worth of a video, but I'm sure it was worth it, hopefully.